Hi to everyone. In this video, let us discuss what are ideal solutions, non-ideal solutions, deviation from Raoult's law. Okay. Now first come to know what are ideal solutions. The solutions which obey the Raoult's law are said to be ideal solutions. Or another one, for the solutions which are having observed vapor pressure is equals to calculated vapor pressure. That type of solutions are also said to be ideal solutions. And what are the conditions required to exhibit this ideal behavior? See here. The first one, if you consider the two liquids or any two components A and B. Now, AA interactions and BB interactions and also A and B interactions will remain the same. That is one condition. And second condition, the two components A and B should have the similar chemical structure and similar chemical size. Then only we can expect this type of behavior. Okay, now for this type of solutions, delta H equals to 0. Delta H means what? Change in heat energy is 0. That means neither heat gained or lost in this process. And also delta V equal to 0. Delta V equal to 0 means if 2 liter of A mixed with 2 liter of B, the total volume is exactly 4 liters. No change in that value, total value. So delta V equal to 0. And for this, delta S is positive and delta G is negative at all temperatures. At all temperatures, delta G is negative. And then in this type of solutions, separation of liquids from the mixture is possible by using which one? Fractional distillation. By using fractional distillation, one can separate which one means A and B liquids from the mixture. Okay, then here examples for such type of liquids or such type of solutions. Let us see here. First one is benzene plus toluene. And second example is here ethyl bromide plus ethyl iodide. Third example is N-butyl bromide plus N-butyl chloride. And fourth example is here N-hexane plus N-heptane. And another example is here chlorobenzene plus bromobenzene. So these are the different examples which are showing ideal behavior. And for this type of solutions, observed vapor pressure is equal to calculated vapor pressure. So we can show with a graph that observed vapor pressure is equal to calculated vapor pressure. How we can draw that graph here? So here XA equals to 1, XB equals to 1, where XA, XB are mole fractions of A and B. XA equals to 1, XB equals to 0. And here XA equal to 0, XB equals to 1. Now we can draw the graph like this here. Let it be the PA and let it be the PB. So here PA is more volatile. That means A is more volatile than B. That's why only A has more vapor pressure than which one? B. So this is regarding which one means ideal solutions. And then come to the second one, non-ideal solutions. So what are that non-ideal solutions? Which are examples for that? Let us see here. So the solutions which do not obey Raoult's law are said to be non-ideal solutions. And another one, for the solutions which we can observe, that observed vapor pressure is not equals to calculated vapor pressure. That type of solutions are said to be non-ideal solutions. And for this type of solutions, delta H not equal to 0, delta V also not equals to 0. And here the separation of that liquids from the mixture is not possible even with fractional distillation. Why? Because of formation of azeotropic mixture. So what is the meaning of azeotropic mixture? So the mixture of two liquids at a certain composition behave as a single liquid, and that evaporate, that means the total mixture evaporate at unique boiling point. So that's why that azeotropic mixture is unable to separate. So like that, even by using fractional distillation, we can't separate that mixture of liquids. And that non-ideal behavior is of two types. First one is the non-ideal solutions showing positive deviation from Raoult's law, and second one, that non-ideal solutions showing negative deviation from Raoult's law. So first let us go for non-ideal solutions showing positive deviation from Raoult's law. Solutions showing positive deviation. What are the solutions showing positive deviation from Raoult's law? Let us see here. Okay. Now, for this type of solutions, observed vapor pressure is greater than calculated vapor pressure. And another condition here, AA and BB attractions stronger than which one? AB attractions. AA and BB attractions are stronger than which one here? AB attractions. So that's why only, as AB attractions are weaker than AA and BB attractions, escaping tendency of A and B when they are mixed is more than compared with in pure liquid state, more than that in pure liquid state. That's why only they easily escape out from the mixture, and due to that they exhibit high vapor pressure. Okay, I repeat again here. The escaping tendency of A and B from this mixture is greater than compared with their liquid state in pure conditions. So that's why only more number of vapors are formed, and that vapor pressure is more than expected or more than calculated. So like that, observed vapor pressure is greater than which one? Calculated vapor pressure. And for this type of solutions, delta H is positive, delta V also positive. Delta V also positive means what that meaning here? If 70 ml of A plus 20 ml of B are mixed with one another, the total volume will become 91 ml. That means here there is a slight increase than the original value. What should be the original value? 90 ml. but there is a slight increase in the volume, not liters of liters, just 1 ml or 2 ml, a slight increase. So that's why only we have to write delta V is positive. And for this type of solutions, delta G is negative, but this is only at high temperatures. Only at high temperatures delta G is negative and delta S is positive. Okay, then after that we have to see the examples of solutions or mixture of liquids which are showing positive deviation from Raoult's law. So the first example is here. What is that first example? Acetone plus ethanol. Second example, acetone plus CS2. Third example, methanol plus water. Fourth example, ethanol plus water. Next example, CCl4 plus toluene. Next example, CCl4 plus chloroform. Next example, CCl4 plus methyl alcohol. CCl4 plus methyl alcohol. So these are the some examples, and another one also we can write here. What is that? Okay, acetone plus benzene. And another example here, cyclohexanol. Cyclohexanol plus ethyl alcohol. So these are the different examples for which one solutions showing positive deviation. So I repeat once again here, acetone plus ethanol, acetone plus CS2, methyl alcohol plus water, ethyl alcohol plus water, CCl4 plus toluene, CCl4 plus chloroform, CCl4 plus methyl alcohol, and another one here, okay, benzene, okay, acetone plus benzene, and cyclohexane. Okay, cyclohexane plus which one? Ethyl alcohol. So these are the examples of solutions which are showing positive deviation from Raoult's law. And for this, one can draw the graph like this here. Okay, let us see the graph related to which one here? Positive deviation from Raoult's law. Okay, what is that graph here? For example, these are which one? Expected vapor pressures. So let it be the PA and PB. Here XA equals to 1 but XB equals to 0. And here XA equals to 0, XB equals to 1. These are expected, but the observed vapor pressure is more than expected. So this is observed vapor pressure. But this is which one? Expected vapor pressure or calculated vapor pressure. Calculated vapor pressure. So this is the graph related to which one? Solutions showing positive deviation from Raoult's law. Okay, then let us see now next negative deviation. So what is the meaning of negative deviation? So the next one is here, solutions showing negative deviation from Raoult's law. So now what are the conditions required to show the negative deviation from Raoult's law? Let us see here. The solutions for which observed vapor pressure is less than that of calculated vapor pressure. So these are said to be exhibiting which one here? Negative deviation from Raoult's law. And another one, AA attractions and BB attractions are weaker than which one? AB attractions. So AB attractions are stronger than which one? AA and BB attractions. So these are the two conditions we have to observe in case of which one? Solutions showing negative deviation. And here that mixture of these two solutions is unable to separate even by using which one? Fractional distillation, because the solutions which are showing negative deviation form azeotropic mixture, that means maximum boiling point azeotropic mixture. That solutions which shows negative deviation from Raoult's law form the that which one here? Maximum boiling point azeotropic mixture. So due to the formation of azeotropic mixture, that components from the mixture is not possible to separate even by using fractional distillation. And for this type of solutions, delta H is negative, delta V also negative, delta G is negative, delta S is positive. Okay, then what are the examples for this type of solutions? See here, the first example is here acetone plus aniline, and second example is acetone plus chloroform, and third example is here HCl plus water, fourth example HNO3 plus water, and another one, fifth example here. Okay, what we can take? Chloroform plus acetone, already we have written that. And then acetone plus toluene, acetone plus toluene. This is another example showing which one? Negative deviation. And after that, methyl alcohol plus acetic acid, methyl alcohol plus acetic acid. And one more example also we can give here. What is that? Acetic acid plus pyridine, acetic acid plus pyridine. So these are the examples for solutions showing which one? Negative deviation from Raoult's law. And for this we can give the graph. In which way? Let us see that. What is the graph present for solutions showing negative deviation from Raoult's law? Okay, now first we have to see that for ideal solutions. So this is for which one? Ideal solutions. We can get the graph like this. But showing negative deviation means observed vapor pressure is less than that of calculated vapor pressure. So this is observed vapor pressure and this is calculated vapor pressure. So like this, these are the solutions exhibiting which one? Non-ideal behavior. Okay, this is regarding ideal solutions, non-ideal solutions. And for competitive exams, what are the questions important from this topic means? First, simply they may ask regarding delta G, delta S, delta H, delta V values. For ideal, showing positive deviation, and also for showing negative deviation. That is one question important. And another one, here examples you need to mug up them. So you have to memorize them. So if you remember that examples, definitely any one of those examples in examination we come to see that. So like that, which of the following showing ideal behavior, or which of the following mixture showing positive deviation from Raoult's law or negative deviation from Raoult's law. Like that we may get the different questions from this topic. Okay, in our next video we will that we will go to see which one here, that colligative properties, what are colligative properties, etc. Okay, bye.